Hello, this is Tommy. Welcome to Chatomics. Today I'm going to show you how to use UCSC Genome Browser to check a transcription factor binding around your favorite gene. So I remember in the early days, I used UCSC Genome Browser a lot to check, for example, CTCF binding around my favorite genes. Okay, so you Google Genome Browser UCSC, you will find this website, genome.ucsc.edu. And if you hover here and let's go to HG19 reference version. Okay, it takes some time somehow to load the genome. Let's wait a little bit. Okay, once you come to this page, so you see there are many tracks here already. So this track is the gene track, as you see here. So you can type any gene name that you want to check. So here I just did BGFA, so it showed here. But you can type other genes, for example, CTCF gene itself. And you can click Go. So it will show you the gene structure of the gene CTCF. Okay, and you see those are the exons here, and the arrow here means the transcription is from 5' to 3' from this direction, and some genes may transcribe from the reverse strand. So you may see actually arrows that is reversed. Okay, so what's really useful for you is this regulation track here. So if you come here, there is a ENCODE transcription factor binding. So you can click this. And there are many transcription factor binding chip sequencing data that are available from those tracks. And we can maybe just check one of them. Click this. And you see the many transcription factors showing here, and those are the cell lines that people have actually performed chip sequencing in those cell lines. Okay, so you can first just deselect all of them by clicking this minus sign here. So nothing is selected here, and we will just check CTCF binding. So CTCF is a zinc finger protein, and it binds to many places of the genome. There are two actually CTCF here, like they use, I think they use different antibody. So this Santa Cruz antibody 5916, I think, was used multiple times in different cell lines. So we can click those. For example, we want to select maybe K562 cell line, HepG2 cell line, and maybe the MCF7 cell line as well. Okay. So after click those, and you can click Submit. Okay. Somehow my computer is a little bit slow. Okay, let's go back to the GMB-GFA first. Go. And now down here you see that those are the three cell lines we just selected, right? K562, HepG, and MCF7, right? And you see the tracks here. Those are the raw signal track. And you have two replicates for the same cell line here. And usually what I like to do is zoom out a little bit, 3x, and you see the binding pretty conserved actually across different cell lines. For K562, you have the binding at roughly at the promoter region of VEGF-A, HepG the same here, and then MCF7 as well. So you can also actually drag those tracks up just to make it a little bit closer to the gene track. So you can drag it up, for example. And you can also change the settings of the signal. For example, if you see a red bar here, that means the signal can be even higher. So if you just click it, we'll go back to the same configuration page, and I believe you can change the raw signal or the maximum display mode. Let me see. Let's go back first. So you can see configure this track. Just right click and it will show you this, and then you will see what's the maximum value you want to actually show. So you can see 100, for example, and you can see apply. Now you see, because the maximum is 100, all those like noises, they become really small, and that's usually I do. So if I know the signal is strong, I will increase the range of the signal here. Okay, this is pretty neat, right? So you can actually select the transcription factors you want from the list and check whether there's a binding around your favorite gene. So in this case, VEGF-A. But in case you want to actually download those data and visualize on your local genome browser, for example, IGV, so you can go to this page, the ENCODE download, and you can find the same chip sequencing tracks that you can download. So it's chipseq. So it should be here, the HAIB TFBS binding sites that we just used. So you can click this and it will bring you to this page for downloading the data. So it actually gives you the band files, the mapped raw band file, and the peak file, which is the region where you have the increased or enriched binding. So this file is relatively smaller. And then we also have the big file, which is the raw signal file. So you want to download those. For example, I want to do CTCF and the MCF7 breast cancer cell line and CTCF. And for example, you can download the big files, and then also you can download the peak files. Okay, I already downloaded the big files, so let me also download the peak files. So it'll be downloaded. Okay, now you're ready to visualize it using IGV. So IGV, so if you don't know it, you should just Google IGV Genome Browser. It is developed by Broad. And after you download, you can just double click and open it. So first you need to select the reference genome here. So we are using HG19 again. So it should match whatever the track that you downloaded. So it's also HG19 here that you downloaded. So now you can go to load from file and load the big file that I just downloaded. So it's a little bit bigger, it's 100 megabyte. So if you just load it, and then you can also load the peak file, which is the peak file here. So you open it, so it'll be like here. So you can, the similar with UCSC Genome Browser, you can drag the tracks and arrange their locations, and you can even make it a little bit closer to the track, the gene track here, the RefSeq genes. So let's still go to VEGF-A, and again, you see those are the 3 peaks that we see also in the UCSC Genome Browser. But then here you want to actually expand the gene structure here, because there's a I think there's a different gene here, so you want to actually expand it. So those are different isoforms of VEGF-A here. So those are exons, the first exon, second, third, and this is the 5' UTR. You see it's a little bit narrow, not as thicker as the other exons, and this is 3' UTR, okay, 3' untranslated region. So you can also change the tracks by, so I usually want to change the track height to, for example, 100, so just make it a little bit visual. And you see those are the peak files, right? The peak files are the genes that are the regions that are identified that have enriched signal of CTCF. So for example, here, and you can, that's why how you check visually how good your data, your peaks are, like comparing with the raw signal. Okay. Yes. And because it's local and it's just much faster, that's why sometimes I prefer downloading the big files to my local computer and use IGV to visualize the binding. And for example, you can look at CTCF again, and you see actually CTCF binds to itself. So this is the promoter region of CTCF, and you see CTCF actually binds to it's maybe first exon here. Okay. Yeah. So if you want to learn more about UCSC Genome Browser, make sure you go to the website and play with it. It's definitely a very powerful tool, and given there's so many chip sequencing data and also histomodification data that are already available here, and if you work on different cancer cell lines, they are probably already ChIP-seq or histomodification data track in this regulation section here. So do make sure you check it out. That's it for today, and I hope you enjoyed it. Happy learning. Make sure you click subscribe to this channel. Bye. See you next time.